Okay, let's go over like terms. So like terms will be two terms, two or more terms that have the same variable and the same exponent. However, their coefficients can be different. So let's go over each of those different points. So variable is going to be a letter that stands in place of a number. A lot of times we use X and Y, but you can use any letter you want. So if we want like terms, then they're going to have to be the same variable, the same letter. So X and Y are different. Those are not like terms. And they have to have the same exponent. So if I had X and X squared, even though I have X and X here, they have different exponents, so they're not alike either. We need to have the same exponent, However, their coefficients can be different. So even if I had 2x squared and 3x squared, those two terms are alike. When we have just a variable and it's not raised to any exponent, the invisible exponent is just 1. And if we have a constant number, then that doesn't have any variable at all. Okay. Let's go through some examples and decide whether these are alike or not. So we have 3x and 4x. Like I said, if a variable does not have an exponent, then we can assume its exponent is just 1. So we have x and x, both raised to the power of 1. And their coefficients are 3 and 4. So coefficients are different, exponents are the same, and variables are the same. So variable, exponent, same, coefficient, different. Therefore, yes, these are like terms. Now let's go on to the next one. We have 4x squared and 2x squared. So variables are the same, and exponents are the same. They're both raised to the second power. Their coefficients are different, but that's okay. These are still like terms. Now we have 7 and 9. These are both constant numbers. And just think about it. Can you add 7 and 9 together? Yes. Those are like terms. Like terms. Now we have 1/4 and 12. 1/4 and 12. This one might look like they're different because we have a fraction and a whole number, and you can't just add them as simply as you would 7 and 9. But these are still just regular old numbers with no variables, no exponents. So these are like terms. Let's go to 4y and 5x. So their coefficients are different, but that's okay. However, we have y here and x here. So those are different variables. Same exponent, they're both raised to the power of 1, but different variables. So no, these are not like terms. Okay, we have 6y squared and 12y squared. Those y squareds are what we're looking at. Variables are the same, exponents are the same, coefficients are different. So yes, they are like terms. Now we have 4x squared y. We have two variables here in these terms, and 8x squared y. However, both of those variables are the same, and the exponents are the same. The x is raised to the power of 2, y is raised to the power of 1. Same over here, x squared, y to the first. Coefficients are different, but that's okay. These are like terms. Now we have 6xy squared and 5x squared y. So we still have the same variables. We have x and y. However, this time, the x is raised to the first power, and the y is raised to the second power. And then in this second term, x is raised to the second power, and y is to the first. So they are different exponents, different coefficients. These are not like terms. Okay, we'll go on by simplifying these expressions by gathering like terms. So what we want to do is rewrite this expression so that all the like terms are with one another, and then we can simplify more from there. So let's start just left to right. We have 4x squared plus y plus 6x squared y plus 7y squared plus 8 plus 9y squared plus 10x squared y plus 4. So we'll start with this 4x squared. 4x squared. Are there any x squareds within this list? No, 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 no. So that's the only one there. And then I'm going to do plus y. I'll do my y's next. So I have y here. I have a y here, but it's not just y on its own. It's x squared y. So that's not going to be a like term. So I can't combine those. Same with this. This is y still, but it's y squared. So I can't use that. No, 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 no. Okay, so then let's move on. And I'm just marking these as I go so I make sure I don't miss anything. Let's do this 6x squared y. X squared y. This would not be alike, not alike, not alike. But this one is, we have x squared y, x squared y. So I'm going to do plus 10x squared y. Then we have 7y squared. Add 7y squared. So I have 7y squared here. That 8 is different. Then I have 9y squared. I took care of that. And then the 4. So then all that's left is the 8 and the 4. Plus 8 plus 4. So I have 4x squared plus y. And now I can combine these two terms together. So if I have 6x squared y and 10x squared y, I end up with 16x squared y. Then plus 7y squared plus 9y squared. So 7 and 9 gives me 16y squared. And then 8 and 4 give me 12. And that's my simplified expression. Let's go on to the next one. I have 9a minus 4b plus 7a squared b plus 10b squared minus 6a squared b minus 3b squared plus 2b plus 14 minus 7a plus 2. So let's start with this 9a. I have 9a. The 4b, that's not alike, so I can't add it, 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 cannot add it, can't add it. Aha, but this one I can. That negative 7a. So when we have a subtraction sign, that gets included with this coefficient. So it's not just 7a, it's negative 7a. So do minus 7a. Okay, and then I'll move on to my next term. I have negative 4b. Again, that subtraction sign is included in the coefficient. Negative 4b. That doesn't work. That won't work. That won't work. That won't work. But this one will. Plus 2b. Okay. And then these two are constants. Move on to 7a squared b plus 7a squared b. Do I have any other a squared b's? Not there. Aha, but I do there. So minus 6a squared b minus 3b squared plus 14 plus 2. Okay, so now I have 10b squared minus 3b squared. Okay, and then plus 14 plus 2. Now I can simplify. So 9a minus 7a gives me 2a. Then negative 4b plus 2b gives me negative 2b. Plus 7a squared b minus 6a squared b gives me 1a squared b. So I can just write a squared b. I don't need to write that 1 there. And then 10b squared minus 3b squared gives me 7b squared. And then 14 and 2 give me 16. And that's my simplified expression. Got one more to do. Let's see if I can fit it in here. So I have 12q plus 8p plus 4 minus 12q squared plus 16 minus 8p plus 4q squared minus 7q plus 9p plus 6 minus p squared. So I'll start with my 12q. And I'm just starting with that one because it's written first. You could really start anywhere you wanted. So I have 12q. I look around to see if I have any other q's. I have these q squareds, but I can't have those. But I have this minus 7q. Then I have 8p. Do I have any other p's? Yes, another minus 8p. Any others? Plus 9p. And then p squared. Okay, now I have my constant plus 4. Another constant here, plus 16. Plus 6. Then I have minus 12q squared plus 4q squared. And then minus p squared. So 12q minus 7q is 5q. 8p minus 8p is 0. So that will cancel out. But then I get 9p plus 14, plus 4 plus 16 plus 6 gives me 26. Then I have minus 12q squared. Put those together. So minus 12q squared plus 4q squared gives me negative 8q squared minus p squared. And that'll be my simplified expression.